In this video, let us see the Cayley-Hamilton theorem with an example. Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. The applications are to find the higher powers of a given matrix and the characteristic polynomial of a matrix and the inverse of a given matrix. Let us see to verify the Cayley-Hamilton theorem of a given matrix and hence find the inverse and higher powers of a matrix. So first we will find out the characteristic equation of a matrix. The characteristic equation of a matrix is given by det of A minus lambda I equals to 0. So the equation is defined as lambda cube minus the trace of a matrix 2 plus 2 plus 2 into lambda square plus det. So minus of a principal diagonal elements, that is det of 2 minus 1 minus 1 2 plus 2 1 1 2 plus 2 minus 1 minus 1 2 into lambda minus det A equals to 0. So on simplification we get lambda cube minus 6 lambda square plus 9 lambda minus det is equals to 4. So equals to 0. So this is the characteristic equation of a given matrix A. So by Cayley-Hamilton theorem, the statement is given by every square matrix satisfies its own characteristic equation. So that is, here we get instead of lambda, now it is going to be satisfied with a matrix A minus 6a square plus 9a minus, here in this place we will write it as I, 4i equals to 0 matrix. So this is to be verified now. We will see the verification. So this is to be verified here by the given matrix A. So matrix A is given as A equals to 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and it's A square. So first of all we need to find out A square and A cube values. So A square value is given as 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6, and next find out A cube. So A cube is equals to 22 minus 21 21 minus 21 22 minus 21 21 minus 21 22. So after finding this A square and A cube values, substitute in these polynomial in terms of A. So that is now A cube minus 6a square plus 9a minus 4i. Substitute it here. So 22 minus 21 21 minus 21 22 minus 21 21 minus 21 22 as a cube minus 6 times of a square value. So that is 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6 plus 9 times of A. Matrix, given matrix is 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2 minus 4. So now the unit matrix is what? Of order 3. So write here 1 0 0 0 1 0 0 0 1. And now solve its corresponding values, the first row, first element, and make that sure that, and see that its value will be equals to 0 0 0 0 0 0 0 0 0. So hence we can say that, so the characteristic equation of a matrix is satisfied by the matrix A, that is A cube minus 6A square plus 9A minus 4I equals to 0 matrix. The characteristic matrix is satisfied and it is verified. Let us find the inverse and the higher powers of a matrix. So to find inverse, by using the Cayley-Hamilton theorem statement. So that given as, so according to the Cayley-Hamilton theorem, it is given that every square matrix satisfies its characteristic equation. So the characteristic equation is satisfied by the matrix A, that is A cube minus 6A square plus 9A minus 4I equals to 0. So by using this characteristic equation, we are going to find out inverse. So to find out the inverse, multiply with A inverse on both sides. So here A inverse times of A cube minus 6A square plus 9A minus 4I equals to 0. So multiply with A inverse to each of the term, we will get here A square minus 6A plus A inverse into A is 9I minus 4 into I into A inverse is A inverse equals to 0. So from this we need to find out only the A inverse value. So A inverse is equals to 1 by 4 times of A square minus 6A plus 9I. Now substitute 1 by 4 times of A inverse A square value minus A value and I value in this condition here. So A square is equals to 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6. This is A square minus 6 times of A, 2 minus 1, 1 minus 1, 2 minus 1 plus 9 into the unit matrix 1 0 0 0 1 0 0 0 1. So its resultant value is given as A inverse is equals to 1 by 4 times of 3 1 minus 1 1 3 1 minus 1 1 3. So this is the way to find out the inverse of a matrix. Now we will see that how to calculate the higher powers of a matrix. To find A to the power of 4. So once again, by using the Cayley-Hamilton theorem, write down the characteristic equation satisfied by the matrix A, that is A cube minus 6A square plus 9A minus 4I equals to 0. Okay. To find out the higher powers of a matrix A, so we are going to find out A power 4, multiply the given equation with A. So pre-multiply. So into A cube minus 6A square plus 9A minus 4i equals to 0. So multiply, we'll get here a power 4 minus 6a cube plus 9a square minus 4a equals to 0. So we need to find out the a power 4. So write down here a power 4 equals to 6a cube minus 9a square plus 4a. And again substitute a cube value, a square value and a value. So finally we'll get a resultant value of a power 4 as 86 minus 85, 85 minus 85, 86 minus 85, 85 minus 85 and 86. So in this video we learned how to find out the characteristic equation, and that characteristic equation is satisfied by the matrix A. That is our Cayley-Hamilton theorem, and using this Cayley-Hamilton theorem we have found out the A inverse and higher powers of the matrix A for a power 4. Thank you.